Good morning. Today we are going to learn the new concept of data structure, that is the queue. So let's see the hierarchy. As you know, what is data structure? Data structure is the way of storing, that is organizing, storing, accessing, modification, that is manipulation. Okay, manipulation of data for a future use. Okay, that's called as a data structure. Data has kept in the form of structure, organized way. So this is categorized into primitive, non-primitive. Now, if you comes with the what is the definition of the queue here? So the queue is what it is linear. How data is stored? Linear. Linear means the data you are going to store into the sequential way. Sequential way, and it is non-primitive data structure. So how we are going to define? The definition of that is the queue is a linear non-primitive data structure. So the definition is the queue is a linear. The data is stored in a sequential manner. Linear, it is non-primitive, means they are not directly operated by the machine instruction. Primitive means in float built-in data type. Primitive data structure. Okay, so what it do? It follows. What it follows? It follows first in first out mechanism. What it follow? It follow first in first out mechanism. For example, when you had a stack, there only one end was there. There is only end, that is the top of the variable, but it is a queue. Consider that for real time example, this is a queue, whereas this is a stack. Okay, here assume that it is an idli cooker. As you are inserted first, that is last in, first out, or first in, last out mechanism it work. But it is a queue. Okay, it is a queue. The first element is inserted will be the first out. So first inserted is to be first served or first out. So this is the mechanism where the element inserted first, say that will be removed first. First element inserted, what happened here? First element inserted will be removed first. Will be removed first. Hence, it called as a FIFO mechanism. I repeat, what is Q? Q is a linear. So, how the data is storing? That is a sequential manner. The data is stored in a sequential manner. Linear, non-primitive. Non-primitive means it is int Q of 5. So, what is the data type it is? Integer. And how many elements are there? 0, 1, 2, 3, 4. So, that is 4 elements are present. Hence, it's called as a non-primitive. Why it is called data structure? It follows organized way of storing, manipulating the data for a future use. And it has the first in, first out mechanism. Okay, so this is the definition of the queue, where the elements are inserted. The insertion end is called as the rear variable. Which variable is used for insertion? Rear. From where it is deleting? It is from the front. Okay, this is an example with respect to the real time, as you are here for in a queue to ticket. Okay, so here n numbers of member. So one who comes first, they comes first, then they will exit first. One who enter first, they will exit first. Hence, it's a mechanism called FIFO. So its representation is like this. Okay, so 0, 1, 2, 3. So first element has 20 entered, it will come first. Then 30, then it comes first. Second, next 40 or 30, then 50. So here the first entering element, the first will be out. Okay, this is a real time example, but with respect to the implementation, here we are going to use a two variables. Okay, so assume here this is a queue of the maximum size n equal to 0, 1, 2, 3 and 4. So what is the size here? N equal to 5. Okay, the two variables. As for a stack, only one variable we call, that is the top of the stack. But here what happening? There are two variables. It's very important. There are two variables we are going to use as the pointers. Okay, they are the two variables used as a pointers. pointing to for what? One for a insertion and another for the deletion. So insertion is called as a NQ operation, whereas a deletion is called as a DQ operation or a method. Okay. So insertion, that variable use here as a rear variable. For deletion, you are using the variable called front here. Okay. These are the two variables. Now assume here, initially, now here, both are pointing to here because the first element is inserted as q of 0. Then first element need to be removed as q of 0. Second element is q of 1. Then inserting the 1, that is 20. Now I have inserted here. So q of 0 has been inserted and that value is 20. Now who is pointing to this? This is pointed by the rear variable. Okay. Now if I delete, from where I have to delete? I have to delete from here itself. So one variable which consider for the insertion and another variable which is considered for the deletion. Okay, there are two variables. Now q of rear, I have to increment the rear by 1, rear plus plus, then that is q of r is equal to the element. Now similarly, now rear reaches to, now r is here, then r comes here, then r comes here, then r comes here. Okay, 5 not 1. So rear reaches to, r reaches to 3. Now I want to delete the element. So how to delete that element? Because rear is at 3. Okay, so we need to delete the q of 0. So initially, hence, this front value should be assigned to 0. So the front of 0th element I have to remove. Okay, so that operation is called as a deletion. Please remember, deletion operation is pointed by one variable, that's called as a front of the variable. Then the insertion operation is to be called as a rear of the variable. These two are the pointers which are used to represent for the concept of insertion and deletion. Okay, so what are the types? What are the basic ADTs we can perform here? Basic ADTs. What are the basic operation? First is insertion. For that, we are using the variable called rear, and this is represented in here as enqueued method. Okay. Second, deletion. That variable we are using as, this is the operation, and this is an method. Okay. So here the variable is front, and this is called as dequeued method. Okay. Next, third one is traverse, display the elements from the list. Here you can go by using both the variable from front to rear. You have to start from the front and you have to go to the rear, and this is called as a display method. Then we have to check that the operation is whether it is a full. Full means I have to go with, when it is full, when it reaches to rear is equal to maximum size minus 1. Then this is called is full method. Then fifth one, empty, to check that the queue is an empty. Then here, when this is empty, there are two cases. When front is equal to minus 1, or and, or you can use here rear equal to minus 1. Rear is equal to minus 1 and or when it reaches the front is greater than rear case, then that is called as is empty method. Okay, so these are the 5 operations where 3 are the basic, other 2 are the supporting to that basic one. So these are the, once again I repeat here, the operations what are we are going to call, then the variables we need to use, and what method it to be represented. If you want to insert the variable you need as rear, initially the rear value like top value in stack is assigned with minus 1. Here it is assigned with minus 1 because insertion starts from here. So it is initial value, assigning the initial value. Okay, so from rear, and that is represented by enqueued method. Whereas deletion, that is with the front variable. Initially, if you want to delete the first element, that is assigned to 0, because queue of front element, that is 0th element, is removed first. So that is being performed by dequeue operation. When you comes to the traversing display, then how it will go? Then for I equal to, it is assigned to the front, then it should go up to equal to the rear, then I plus plus. So it is going to give you the traversing. Then comes with the full. You have to check rear is equal to maximum size 1, then the queue is full. Then empty, when it is empty, there are two. Either you can use front equal to -1, or you can use rear equal to -1, or front is greater than or equal to rear. Then this is condition. These are the basic ADTs. Let us see what are the applications of the queue, where all this key is to be used. Okay, there are the different applications of queue. First one is memory management by the operating system. Memory operations. Okay, so what are the operations here? By the memory, like processing, CPU processing by OS. That is, it may be the spooling, it may be the CPU scheduling. CPU scheduling. Okay, there are three types of scheduler. When it comes to the scheduling, there are three types. One is a medium term scheduler, one is a long term scheduler, okay, and another one is a short term scheduler. This itself is called as a CPU scheduler also. Okay, so here that is the CPU scheduling. How it is the queue is used here? How the application? Assume that there is a CPU. As assume that the CPU is a teacher. Okay, CPU is a teacher. Here n number of students. S1, student S2, student S3. Okay, so these students are represented here in the computer as processes. And where they are stayed, that staying is called as a job pool. What it is called? Job pool. Okay, now it applies the different, these processors, they have some work to do. What they have? Some work to do. That is measured as a burst time. What is it called? Burst time. Assume that student 1 have the 2-minute task, student 2 have the 10-minute task, and student 3 has 5 minutes task. To whom? With this teacher. So here teacher is said as a CPU and the students has been represented as a process P1, P2, P3, and these minutes are represented as a burst time that are always into the nanosecond or millisecond. Nano or milliseconds. So now, what is how the is application is used here? By using a short time thing, we have the different it may be the first come first serve, first come first serve. One who enters first, the first student entered here P1 first, P2 first, and P3 first. The first student is assigned. The first student is assigned to the teacher for his work. Then second P2, then P3 assigned. So this is first in, first out. Okay, so in this way, the queue application can be used. So second one is, the second application for that is the network, data transmission on the network. You want to transmit the data transmit on network. Okay, network. From source to destination, you want to pass, that is in the form of, okay, that is the third, the second one. Third application, it will come as any queue line, any queue line work. Okay, that can be done with this. And the implementation of BFS, that is breadth first search. Breadth first search can be implemented by using a queue. So these are the some of the applications of the queue. Thank you.